Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning guys. Good morning Pei Chong. Good morning Amanda. Waalaikumsalam Sam. Waalaikumsalam Nurin. Good morning Abby. Hi Syah. Waalaikumsalam Umi. Waalaikumsalam Aisyah. Waalaikumsalam Hana. So I can see many S1 to A6 12 students, yeah. Okay, so I hope you guys are now ready, okay, for our lecture this morning. Alright, I don't intend to discuss topic 9 today because we still have time. Okay, so rather I would discuss some of the past year questions, okay, involving topic 8 to strengthen your knowledge, okay, in this topic. Why? Because this topic is covered in your group assignment, and also this will be tested in PSPM. Okay, so you have to really understand this topic so that you will be able to tackle the question. Okay, good morning Zilong. Okay, Waalaikumsalam Diana. Alright, so now let's begin the discussion. Okay, so today I will discuss past year question which you can't find in your tutorial book. Okay, but before we discuss the question, let us recall, okay, the content in topic 8. Okay, so here we do have the summary. Okay, so let's go through here, okay, the basic laws of probability. So we will be applying this, okay, in order to solve the past year questions. All right, we will be applying this quite a lot now. Okay, so you need to understand these five five contents here. Okay, so first you have to understand the probability, the concept of probability. It has to be between 0 and 1. Okay, and we know that sum of probabilities, okay, is 1. And then complement rule. Okay, so let's say if you have an event A, so complement of A, which is A prime or A bar, is 1 minus PA. Okay, and then this is additional rule, okay, where we have probability of A union B equals probability of A plus probability of B minus probability of A intersect B. Okay, and then for conditional probability, okay, conditional probability is the probability of an event provided that the other event has already happened. So in order to apply this formula, okay, so usually the event written at the back is the event which has already happened. Okay, so if you are given in the question, okay, the event that has happened, you put at the back. So by applying the formula, okay, so let's say if you want to find probability of A given B, so the formula will be probability of A intersect B over PB. Or if we change the formula, so let's say if the event A has already happened, so what is the probability of B? So you just apply the formula. Okay, so it will be probability of B intersect A divided by probability of A. Okay, so you see the event that has happened will be at the back and also in the denominator. Okay, so that's the idea. Okay, so now let's begin the discussion. Okay, so here we'll choose past year question 2014. Okay, so if you do have time, we will cover this 4 years, yeah, 14, 15, 15, 16, 16, 17, and 17, 18. Okay, so now let's go through one by one. Okay, this is past year question number 14 and 15. Alright, so now let's go through the question. Okay, so the idea is whenever you, okay, you read the question, okay, and right after that, please do refer the total marks, yeah, the marks provided, the marks allocated, because, okay, in PSPM, you need to allocate your time, yeah, you need to manage your time very wisely. Sometimes the problem with students is not that they do not know how to solve, the problem is with their time management. Okay, so if you are given 7 marks, make sure you try to solve this question within 7 minutes only, yeah, so 1 mark is equivalent to 1 minute. Okay, so make sure you comply this. Okay, so now let's begin. Let's start discussing the question. Okay, we are given probability of A intersect B prime equals 0.25, probability of A equals 0.48, and probability of B equals 0.42. Okay, find probability of A intersect B. Okay, so this is the first part of the question. And second part, the question says, okay, it should be R here. Okay, A and B mutually exclusive events. Okay, so this is the second part of the question. We need to answer whether they are or they are not mutually exclusive. and hence determine whether they are independent. So this question consists of 3 parts. Okay, so first we need to find intersection, probability of A intersect B. How can we do this? Okay, so if you refer, okay, we are given A intersect B prime, right? So if you draw the Venn diagram, so A here and B here. So A intersect B prime, the region is actually here. This is the region where A intersect B prime, right? So we include all the A but not B. So but not B means, so how can we obtain this region? So probability of A intersect B prime is equal to, so first you just get the whole circle here, PA, and then you subtract this region. So the region here is A intersect B. Okay, so this is the formula, the other formula. Okay, you can find this in the summary. Okay, so this is the formula that we have. Okay, now because we are given A intersect B prime, so we substitute the value. We are also given PA, we substitute the value. So this is the one that we need to look for, right? So okay, by writing down the probability of A intersect B as the subject, so you will have probability of A intersect B to be 0.23. Okay, so this is the answer for the first part of the question. Alright. Okay, and then, okay, let's answer second part of the question. The question says, are A and B mutually exclusive events? Okay, so now let's recall the concept of mutually exclusive events. Okay, we can have two events to be mutually exclusive, okay, if they cannot occur at the same time. Which means, okay, in this case, the probability of intersection will be 0. Okay, so again, mutually exclusive. Alright, so you remember the word exclusive. So if the two events are exclusive, which means they cannot occur at the same time. Okay, so whereby the intersection between the two will be 0. Okay, so now let's come back to this question. Okay, so the question says, are A and B mutually exclusive? Okay, so now, because we have got the probability of the intersection, right? Okay, you can see here, probability of A intersect B is equal to 0.23. Okay, so in order to answer the second part of the question, so we can just make a conclusion here. Since probability of A intersect B is equal to 0.23, which is not equal to 0, thus A and B are not mutually exclusive. So this is our conclusion. Why? Because again, if they are mutually exclusive, then the intersection will be 0. Okay, the probability of A intersect B will be 0. Okay, so that's the second part of the question. And then third part, hence. Okay, hence determine whether A and B are independent events. Okay, what are independent events? So now let's recall independent events. Okay, so we have this independent events. If two events are independent, okay, so the occurrence of one event does not affect the probability of occurrence of the other, which means PA given B equals PA. So if PA given B equals PA, okay, so if we cross multiply, so we can have this PA times PB equals PA intersect B. Okay, so we had discussed this earlier. Okay, so if they are independent events, so PA times PB is equal to PA intersect B. Okay, so now we have got, okay, coming back to this question, okay, we have got our PA. So this is our PA. And we have got our PB as well. Okay, so now we are going to multiply these two. So PA times PB is this, which is equal to 0.2016. Okay, then if we compare with the previous answer that we had earlier, so PA intersect B is equal to 0.23. So if you can compare these two answers, okay, in terms of values, they are not equal to each other, right? So 0.23 is not equal to 0.2016. Thus, okay, since PA times PB is not equal to PA intersect B, thus A and B are not independent events. Okay, so I hope you understand the concept between mutually exclusive and independent events. Okay, again, mutually exclusive events are where the two events cannot happen at the same time, while independent events means the occurrence of one event does not affect the occurrence of the another event. Okay, so in this case, if they are independent, so PA times PB equals to PA intersect B. But now because the values are not equal to each other, so our conclusion is they are not independent events. Okay, so I hope this is clear enough. So if you have any question, so you can simply write down in the live chat. Okay, so good morning Miaulian. Okay, Waalaikumsalam Farhan. Waalaikumsalam Khair. Salam Aisyah. Morning Bon. Okay, noted Iza. Waalaikumsalam Nurin. Good morning Jiva. Okay, so I hope even though it's a rainy day here, okay, today I hope it doesn't stop you from being enthusiastic, okay, towards learning mathematics. Okay, so it's kind of challenging, right? Okay, to listen to maths lecture, okay, in this cloudy day. But yeah, so maths is rather important than sleep. Okay, so I hope you can stay with me until the end. Okay, so now let's discuss the next question in this particular year, 14-15. Okay, so we are given this question. All right, so let's read the question. In a college, there are 150 students taking courses in chemistry, physics, and biology. Among the students, 92 are females. Okay, so among the students means among these 150. Among these 150, 92 are females. Okay, so how do we do this? All right, so now we need to construct a table. So we construct a contingency table for this given data. Okay, we know that the total of student is 150. So we put the 150 here. Okay, because the question says taking courses chemistry, physics, and biology. So we put the events all here. Okay, and we declare letters. Okay, we denote some letters for the events. So I denote letter C for chemistry, letter P for physics, and letter B for biology. Okay, now and the next events, are about the gender, right? So it's either female or male. Okay, then I declare F for the female and I declare the letter M for male. Okay, and I need to remind you that whenever you choose letters to represent events, make sure the letters are not identical. Okay, let's say here if you have chosen chemistry, C for chemistry, so don't put the letter C for for other subjects or for the genders, because we don't want to get confused. We cannot have one letter to represent two events. Okay, so that's one thing. Okay, now we know that out of this 150, 92 are females, so we put 92 here, okay, for the female event. Okay, and then there are 48 students taking chemistry, so 48 students here taking chemistry, so this is the event of chemistry, right? Okay, so 48 taking chemistry regardless of gender, and it stated which 28 are female. So out of these 48, 28 of them are females. Okay, then half of 68 students taking physics. So there are 68 students taking physics, and then half of them are female. So half of 68 is 34, right? Okay, then we will have 34 here. Okay, so now based on the informations here, okay, so the first thing that you have to do in exam, let's say if you come across this question, is to transfer all the informations given in the table here. Okay, now after we are done with the data transfer, now it's the time to complete the table. So how to complete table? Okay, so now we may insert this. Okay, what is the value here? So it's 150 minus 48 minus 68. Okay, so you will have the value to be 34 here. Okay, and then how to fill in this? Okay, so we know that this is, the row here representing, the female students, right, taking different subjects. So 92 minus 28 and 34. So 92 minus 28 and 34 will give you 30 here. And now you know 34 minus 30 will give you 4 here. Okay, then how to fill in the rest? So 68 minus 34 will give you 34. And then 48 minus 28 will give you 20. And then if you add this, so you will have, 58 here. Okay, so now our table is complete. So the 3 marks allocated, for the table. So once you get the correct table, so you will be given the full marks, Alright, okay, so now after we have the table, so we may proceed with the next question. Okay, a student is chosen at random. So a student. So when a student is chosen at random, so our NS will remain the same. So NS is just 150 C1. So it's still 150. So in this case, NS is still 150. Okay, a student is chosen at random. So find the probability that the student takes biology. Okay, so why do we have to denote letters just now so that it would be easier for us to solve the question? Okay, because we had denoted letter B, right, for biology. Okay, so since the question asks for probability that the student takes biology, so now we know that this is the probability of B. Okay, so PB, now you may, okay, just total up this. So 30 plus 4 will give you 34. So okay, regardless of gender, so we just take the total students taking biology. So 34 out of 150 is 17 over 75. Alright, so you see there is only one mark here, so don't spend too much time on solving this question. Okay, because the value can be directly obtained from the table, right? So you just bring down the table, the value, and you simplify using calculator. Okay, and then next, the question says, find the probability that the student is a male given that he takes biology. Okay, so whenever you are given this, okay, given that, so that means it's a conditional probability. Okay, because why? We have one event that has already happened. So this event has already happened. We know that the student takes biology. Okay, so we know that the student takes biology. So what is the probability that the student is a male? So if the event here has happened, so we put it at the back. So we know that, okay, he takes biology. So what is the probability that he is a male? So now, okay, we use conditional probability formula. Yeah? So this is conditional probability formula. Okay, so using formula, so we have probability of M intersect B over PB. So where can we obtain M intersect B? So you refer the table here. So M intersect B. So you see the value here is 4 out of 150, right? So we put 4 out of 150 divided by PB. So what is our PB? So we can obtain from either previous answer here, or you can get from the table 34 over 150. So you press calculator, so you will have 2 over 17. So again, 2 marks here, so don't spend too much time on solving this, yeah. Okay, so 2 over 17. Alright, okay, then next. Okay, the question says, find the probability that the student takes biology or a female. So because the or here, okay, so which means it's a union. Okay, so in this topic, whenever we come across or word, means union. So, okay, biology, we denote letter B, right, to represent this event. And female here, we denote letter F just now. So, we are looking for probability of B union F. And okay, in this case, whenever you have union of two events, we cannot obtain the value directly from table. Okay, the value cannot be obtained directly from table. Instead, we need to use a formula. So, this is additional probability formula. So this is additional probability formula. Okay, so and this formula will be provided, so you don't really have to worry. So probability of B union F is equal to PB plus PF minus probability of B intersect F. So where can we find the probability of B? So you can obtain from the previous answer, 17 over 75 plus with PF. So PF is probability of female. So regardless of the subjects they are taking, so female, okay, the total of female students is 92, right? So probability of female is 92 over 150. And then minus with B intersect F. So you can see here B intersect F. So you can see the number here is 30. So 30 over 150. So this is 30 over 150. And you just press calculator. Okay. And you will obtain the answer to be 16 over 25. Okay. Alright, so basically that is solution of 2014-2015. Yeah, so these are questions involving topic 8. Okay, so where we use the contingency table to solve this problem. Okay, so again, if you have any questions, so you can ask in the live chat. Yeah. Okay, Waalaikumsalam Izazi. Good morning, Jeannie. Okay, so now let's continue. Okay, so we are done with 14-15. Now next we discuss 15-16. Okay, 15-16 here for number 4 we do have, okay, 7 marks allocated. So again, 7 marks means 7 minutes only. So how to solve this question? Okay, we are given PA equals 0.37. Okay, and we are given B given A equals 0.13, and we are given this PA prime intersect B equals 0.47. Okay, how can we find PA intersect B? Okay, so we can make full use of this information, yeah? Okay, because this is conditional probability, right? So from this probability, so probability of B given A, we know that the formula is B intersect A over PA, right? Okay, so we are given the value here 0.13, so we substitute. And then, okay, this is unknown because this is the one that we are looking for. And then we plug in the probability of A into the formula 0.37 here. Okay, then in order to find probability of B intersect A, so we just cross multiply, okay, this value. So 0.13 times 0.37 will give us 0.0481. Okay, and you don't really have to worry because actually B intersect A is simply equal to A intersect B, okay, because actually they are referring to the exactly the same region, yeah. So let's say you have event A here, you have event B here. So this region is just B intersect A or also equal to A intersect B. Okay, so they are actually the same thing. All right. So this is the answer for the first part, okay, or for the A part. So A probability of A intersect B is equal to 0.0481, which is the product of two values just now. Okay, now find PB. So for the second part, okay, we need to find PB. So how can we find PB? All right. So previously we have made full use of this formula, this information. So now it's about using this information. Okay, so the information given is A prime intersect B. So where is the A prime intersect B? So if you draw Venn diagram, so this is A, this is B, right? So A prime intersect B. So which means not A intersect with B. So this is the region. This is the region where not A or A prime or A bar intersect with B. So this is the region. Okay, so how can we get this region? So it's first you just take the whole circle PB and then minus with this region A intersect B, okay? Or you may notice that this is the other formula that we discussed. Okay, you may find this other formula in the summary that I have provided you. Okay, so now probability of A prime intersect B is equal to PB minus probability of A intersect B. So, okay, we are given the information just now is 0.47 here. Okay, we substitute the value 0.47 and then PB remain unknown, okay, because we do not know what the value. And for A intersect B, we have got the value earlier, so we just bring it down. Okay, so now we have got the value of B equals 0.5181. Okay, and then hence, calculate PA union B. Okay, PA union B prime, yeah. Okay, so you may notice that, okay, there is a prime there. Okay, so PA union B prime, so if we try to draw the Venn diagram, okay, A union B prime is basically this region. We have A here, we have B. So A union B will be the two circles. So A union B prime is everything outside the circles. A union B prime. So how can we get this value? Alright, so first you need to find A union B. Okay, so this is what we will do. We find the probability of A union B first. Okay, so using additional probability formula. So this is additional probability formula. Okay, so whereby probability of A union B is equal to probability of A plus probability of B minus probability of A intersect B. So we have got all the three values. So we just plug in. So we will see the answer to be 0.84. And now because we need to find the probability of A union B prime, right? So prime means this is complement event, yeah? So this is complement event. Okay, so this is complement event of A union B. Okay, so which means we have got the probability of A union B. So it's just 1 minus probability of A union B. So you will see here 1 minus 0.84 is equal to 0.16. Okay, so all of this will give you 5 marks for the B part and 2 marks for the A part. Okay, so make sure you only allocate 7 minutes for this kind of question. Okay, so I would say this question is quite straightforward. Okay, where we need to apply some formula and you just need to make sure that the formula that you are using is correct. Okay, so now let's continue. Okay, Number 7. Okay, so we are given this. A car insurance company offers two types of insurance plan for privately owned cars, namely Plan X and Plan Y. Okay, so we are talking about insurance plan, okay? So X and Y. Okay, then for a random sample of 60 clients for each insurance plan, the number of claims is given in the following table. Okay, so now we do have, okay, the X and Y here represent the insurance plans. Okay, we have Plan X and Plan Y. And here the event here, yes, no, is about whether the whether the client made a claim or not, okay, for that particular insurance plan, okay. And in this case, we cannot simply denote any letters. Why? Because it has been declared in the question here. Okay, so we cannot simply put Y to represent the event yes, and we cannot put the letter N to represent no. Why? Because again, it has been provided in the question. So we don't have any option. We have to use the letters that being used or being declared in the question. Okay, so now we are given letter A. Okay, letter A to represent the event that no claim is made. So again, A represent the event of no claim. So if we refer the table, so no claim made is represented by letter A here. So you can see that I put letter A there. And then if A represents no claim, then we know for sure A prime will represent claim being made, yeah, because it's the complement event of it. And then the B here is representing the event that the customer takes plan X. So you see the letter B for plan X. So here letter B for plan X, yeah, which means for plan Y we use B prime, which is the complement event. Okay, so we try to avoid using too many letters. Okay, we just use the letter A and its prime to represent the complement event, and we also use the B and also B prime to represent the complement event of B. All right. So now the question says find A intersect B. So since we have denoted all the letters respectively for the events, so now we need to find A intersect B. So in this case, you can see that, okay, in the table, okay, where is the region A intersect B? So now this is your A and this is your B. So A intersect B is this basically, okay. So it's 22 divided by 120. So 22 divided by 120, and you just use calculator to simplify. It's 11 over 60. Okay, so there are only 2 marks allocated. So again, don't spend too much time to solve this problem. Okay, and then question says find probability of A union. Okay, so again, okay, whenever you have union, so please take note, okay, please be reminded that, okay, this value cannot be obtained directly from table, yeah. So for any union of between two events, we cannot obtain the value directly from table. So what do? We need to apply additional probability formula. So this is additional probability formula. Okay, so now the question says find A prime union B. So by using the formula, so it's PA prime plus PB minus PA prime intersect B. Okay, so actually the formula is this one, right? The general formula, A union B equals to probability of A plus probability of B minus probability of A intersect B. Okay, but now we are not looking for probability of A union B. We are looking for probability of A prime union B. So here you just change the A to A prime. So you will have A prime here and A prime here. Okay, so please take note. Okay, now how to obtain probability of A prime? So by referring the table, okay, so A prime is basically the total of these two. Okay, we total A prime here, 38 plus 45 will give you 83. So this is 83 over 120. And then plus with PB. So PB here, you just total up these two. 38 plus 22 will give you 60. So 60 over 120 minus A prime intersect B. So where is A prime? So A prime is this one, right? Intersect B. So this is where A prime intersects B. Okay, so 38 over 120. Okay, so it's minus 38 over 120, and you just press calculator, so we will get the value to be 7 over 8. Okay, so again 3 marks here, only 3 minutes should be allocated. Okay, now the question says given that the chosen client did not make any claim. So given that means this event has happened. Did not make any claim, so this event has already happened. Okay, if you recall back, okay, if you refer the table, the event which the customer did not make any claim is represented by letter A, right? Okay, no claim being made, so letter A. Alright, so if the customer or the client did not make any claim, so provided that A has happened, yeah? So this A has happened. Okay, so what is the probability that the insurance plan taken was plan X? So, okay, plan X is denoted by B letter just now. So this is plan X. Okay, so what is the probability that the client takes plan X provided that, okay, he did not make any claim. So again, this is conditional probability, so we just use formula. So it's probability of B intersect A over PA. So again, the event that has happened should be in the denominator. So now where to look for PB intersect A? So PB intersect A you can find from the table. So B here intersect with A here, so it's 22 over 120, yeah. So 22 over 120 and then divided by PA. So where can we find PA? So this is our A. So PA means here 37 over 120. So 37 over 120. So you will have the answer to be 22 over 37. Okay, so this is how we apply the conditional probability. Okay, so again 2 marks only, so don't put too much time, okay, to solve this problem. Okay, so I hope it's good for everyone. Are we good so far, guys? Can you please respond in the live chat? No response so far. Are we good, guys? Yeah, okay, Sam. Okay, good. All right. Okay, this topic is again important, yeah, because this will be tested in PSPM. Okay, so I hope you need to understand this topic. So that's why I feel the need, okay, to discuss some of the past year problems, okay, so that you understand better lah. Okay, all right, good. Thank you for the response. Okay, so now let's continue. Okay, so then next one. Okay, determine whether the events make a claim. Okay, whether the events make a claim and the type of insurance taken are independent. So again, okay, when we talk about independent events, so if, okay, we recall, right, okay, in the summary, if A and B are independent, okay, if A and B are independent, so, okay, the probability of A intersect B is equal to probability of A multiply probability of B. So this is the concept of independent events, yeah. Okay, so now we need to check whether the two events are independent. So the two events are basically make a claim. So again, okay, if you refer the table, the event of making a claim is denoted by A prime, right? Okay, so and then the type of insurance plan taken. Okay, now the question does not particularly state whether the plan is X or plan Y. So in this case, you may choose. All right. So type of insurance plan taken. So in this case, since it's not stated, so you can choose either you want to check whether A prime and B independent, or you can check whether A prime and B prime are independent. Okay. So B here is the event plan X taken, yeah. So here I choose letter B. So in this case, there are two different methods. Okay, it's either you want to check whether A prime and B, or you can also check whether A prime and B prime are independent. Okay, so these are two pairs of different events that you can check. Okay, because in this case, okay, in the question here, it's not stated whether the type of insurance plan X or Y. Okay, so you do have the options. Okay, so for the first method here, okay, we will check whether A prime and B are independent. So first, let's get the probability. So probability of A prime is 83 over 120. Okay, we can obtain from the table. And then probability of B is 60 over 120. So if you multiply the two, we will see that the value is 83 over 240. And if you compare between this value and this, okay, where can we obtain the probability of A prime intersect B? So probability of A prime intersect B can be obtained directly from table. A prime intersect B is this, A prime intersect B. So this is where, okay, the event A prime intersect with B. So this is the value 38 over 120. So in terms of value, if we compare the two, okay, so this is 38 over 120. So if we compare the value, 38 over 120 is not equal to 83 over 240. So in terms of value, they are not equal to each other. Thus, we can conclude that A prime and B are not independent. Okay, so since the question says give reason for your answer, so this is our reason because in terms of values, they are not equal. Probability of A prime intersect B is not equal to probability of A prime multiply probability of B. Okay, or alternatively, you can check whether the event of A prime and B prime, okay, because in the question it is not stated, right, whether the plan taken either X or Y. So in this case we can choose B prime, but you don't have to provide both. So here I put or means alternatively, so this is alternative. So this is alternative. You may choose, but you don't really have to provide both. Okay, so we will check also whether A prime and B prime are independent or not. So first we multiply the probability of A prime and probability of B prime. So this is the value that we have. And then, okay, finding the intersection between A prime and B prime from the table gives us 45 over 120. And if we compare in terms of values, the two values, they are not equal to each other. So we can also conclude that A prime and B prime are not independent. Okay, so that is how we solve this question. Okay, all right. Okay, so I hope we are good enough. Okay, so this is problem, okay, passing question 15-16. Okay, now let's move on to 16-17. Okay, you don't really have to worry, I will give you the solution here. Okay, so we just need to make sure that you understand the working solutions, the steps on how to solve this problem. Okay, so now let's discuss this. Okay, 16-17. Okay, this question is very straightforward. We are given PA and PB. Okay, so calculate, okay, PA union B if events A and B are mutually exclusive. So again, let's recall the mutually exclusive content. Okay, the concept of mutually exclusive events. Okay, so the keyword here is exclusive. Let's say, okay, if I ask you if you do have an exclusive car, what does it mean? There is no other car which similar to your car, correct or not? So when we mention about exclusive, okay, so the keyword you remember, exclusive means there's no such, okay, there's no other thing which is comparable to your thing, okay, to your exclusive thing. So the same thing also to the event, okay, if you have mutually exclusive events, so that means the two events cannot occur at the same time. So in this case, the intersection, okay, the probability of intersection between the two events will be 0. Okay, so now the question says find PA union B. So how can we find PA union B? So in this case, we are going to apply additional probability formula. So this is additional probability formula. Okay, so we have PA union B equals PA plus PB minus PA intersect B. So we are given PA, we substitute here 0.35. We are given PB 0.45, and because the two events are mutually exclusive, so we know that PA union intersect B is equal to 0. Okay, so we will get the value of PA, probability of A union B equals 4 over 5. Or you can simply give the answer in decimal 0.8, no problem. Okay, so that's the answer. So again, 2 marks only. So 2 minutes should be allocated for this particular question. Okay, now the question says find probability of A intersect B prime if events A and B are independent. Okay, so previously we are given if events A and B are mutually exclusive. So now we are given that these two events are independent. So if they are independent, again, let's recall. Okay, independent means the occurrence of one event does not affect the occurrence of another event. So which means probability of A intersect B is equal to PA times PB. So since A and B are independent, so PA intersect B is equal to PA times PB. So we just have the two values, we multiply them both. So this is the value of PA intersect B. Okay, so now the question says find A intersect B prime. So if you draw a Venn diagram, where can we obtain the region A intersect B prime? So A intersect not B, so which means the region is here. So this is the region, A intersect B prime. So how can we obtain the formula? So A intersect B prime means, okay, probability of A minus probability of A intersect B. Okay, so probability of A is given 0.35 and A intersect B has been obtained from previous, okay, step just now. So we just perform the subtraction and this is the answer. Okay, so again 3 marks here, so you need to allocate only 3 minutes. Okay, and then next, okay, let's see this question. Okay, the table below shows the classification of 200 shirts based on sizes and colors. Okay, so now as soon as we get this contingency table, so please denote some letters to represent the events and make sure all the letters are unidentical. Okay, so you cannot choose identical letters to represent two different events. Okay, because we will have problems later. Okay, so in this case, I denote letter S to represent small. Okay, small shirt. Okay, the letter M to represent medium shirt, and L represent large, W here represent white, B here represent blue. Okay, and for the black, I don't use the B letter anymore because the B letter has been used for the blue shirt, right? So, okay, I use the K letter to represent black shirt. Okay, and then after we have denoted all the letters, so we can find the sum first, okay? So we find the sum here, 40 plus 10 plus 25, 75. And then 30 plus 35 plus 30 plus 20 will give you 85. 5 plus 15 plus 20 will give you 40. Okay, then after we find the sum for the columns, now we find the sum for the rows. So 40 plus 35 plus 5 will give you 80. 10 plus 30 plus 15 will give you 55, and 20 plus 20 plus 20, sorry, 25 plus 20 plus 20 will give you 65. Okay, why? The reason we sum this so that later on when we need to find the probability of the events, it will be easier for us to find the value. Okay, so now let's read the question. A shirt is selected randomly. So a shirt. So the keyword here is a shirt. So shirt means one shirt is taken. So in this case, our NS is still 200. Why? Because out of 200, we choose one only. So that's why the NS remains as 200. Yeah? So this is our NS. Okay, so find the probability that the shirt is small in size. Okay, so let's recall we have used letter S, right? Letter S to denote the small shirt. So we are looking for PS. So, okay, because previously we had found the total, okay, so now we can simply find, okay, we can directly take the value 75 over 200 and, okay, we simplify the answer. Okay, so that's why we find the sum earlier so that it will be easier for us here to get the value. Okay, if we need to find the probability. Okay, so this is probability of the shirt to be small in size. Okay, then, okay, for the second part, find the probability whether the shirt, either the shirt is blue or white. Okay, because here either, so it means or. So blue, we use letter B just now. White, we use letter W, right? So we are looking for probability of B union. Why union? Because it's or, yeah, not and. Okay, so again, when you have union, the value cannot be obtained directly from table, right? So which means you need to apply additional probability formula. Okay, additional probability formula. So, okay, now the question says find the probability either blue or white. So, either blue or white. So, by using additional probability formula, so it's PB plus PW minus PB intersect W. So, PB, probability of blue. So, we have got, right, blue here, the total is 55. Okay, regardless of the sizes. Okay, so it's 55 over 200. And then plus with probability of white. So again, regardless of the sizes, it's 80 over 200. And then minus, okay, 0. Why 0? Because the shirt here, they are of different colors, right? White, blue, and black. Okay, so the probability that the one shirt that you choose to be in two different colors is impossible. Okay, because the shirt will be either white or blue or black. You cannot have the shirt to be in both colors. All right, so that's why, okay, the probability of intersection between blue and white will be 0 here. Okay, because, okay, the two events are independent. Sorry, the two events are mutually exclusive events. All right, because they cannot happen at the same time, just like the events of choosing boy and girl. Okay, so if you choose one student, okay, from the classroom, so there is no possibility that you'll be getting a student which is both boy and girl, right? Okay, because we know that the two events are mutually exclusive events. So the same thing applied here, because, okay, if you choose the shade, okay, there is no possibility that the shade will be both blue and white. Okay, so that's why we put 0 here. So, and we just obtain the value, okay, by pressing calculator. It's 27 over 40. Okay, now let's see. Next question. Okay, find the probability that the shirt is medium size given that. So again, the word given that means this event has happened, yeah? Given that it is blue, so it has happened. Okay, so if we recall, okay, we use letter B just now, right, to represent the blue event, and medium size here we use letter M. Okay, what is the probability of M given B? So, okay, probability of M given B, so this is what we need to look for. Okay, and here we need to use conditional probability. So, probability of M given B is equal to probability of M intersect B divided by probability of B, right? Okay, because the event that has happened here, okay, it should be at the back, and in the formula it should be in the denominator. Okay, so how can we obtain probability of M intersect B? So you just refer the table. Okay, M intersect B. So this is M intersect with B. So this is where you can find the intersection. Yeah, it's 30 over 200 divided by PB. It's 55 over 200. Okay, so 30 over 200 divided by 55 over 200 will give you 6 over 11. Okay, so please bear in mind there are 3 marks here, so only use 3 minutes, yeah, okay, to solve this problem. Okay, so that is about this question, yeah, 16, 17. Okay, I hope you are good enough, okay, to listen to this explanation. Okay, no, boleh. Izazi, good, alright. Okay, so last example or last question for today, okay, that we will be discussing is this 17, 18, yeah. Okay, so let's discuss this 17, 18. Okay, so we have this, okay, question. Let A and B be two events where PA prime, so please take note, we have A prime here. PA prime equals 0.7, PB equals 0.4, and PA union B equals 0.6. Determine probability of A intersect B. So this is the first part of the question. We need to obtain the probability of A intersect B and then evaluate the conditional probability. So that's the second part. And third, we need to determine whether A and B are independent, and we need to give also the reason, yeah, state with reason. So there are 3 parts of this question and 6 marks are allocated for this particular problem. So again, only use 6 minutes. Huh? Okay, so now how to solve this question? Okay, because we are given PA prime, which means it's complement event. Huh? So PA prime, so this is complement event. Complement event of A. Okay, so A prime is complement event of A. So now from this A prime, we can obtain PA. So PA is equal to 1 minus PA prime. So PA is 0.3. Okay, now the question says determine PA intersect B. So how can we find A intersect B? Okay, if you notice here, we are given the union, right? The union value. So based on this, we can apply the additional probability formula. So you see, every year here, we need to apply this formula, additional probability formula. Okay, so make sure, so you know this formula. Okay, and you don't really have to worry, it's also provided, okay, in the formula sheet. So okay, you just need to apply this correctly lah. So PA union B is equal to PA plus PB minus PA intersect B. So we are given this value, we already have PA based, okay, from the previous one, and PB also provided. The only thing that we don't have is this. Okay, so you just substitute all the values and you make this as a subject. So you will see that PA intersect B is equal to 0.1. Okay, so first part done. Okay, then the question says then evaluate PA given B. So PA given B, so this is conditional probability. So this is conditional probability. So we just need to apply the formula. Okay, so probability of A given B is equal to probability of A intersect B divided by PB. So whereby probability of A intersect B has been obtained earlier, we just bring down the value, and then PB also given in the question 0.4. So we just bring it down, and then we will have the answer 0.25. Okay, hence. Okay, so please take note in exam whenever you have hence word, which means you have to use previous answers. Okay, so answering how to tackle the third part of the question. Okay, how to check whether A and B are independent events. Okay, so because in this case, we have got the A given B, right? So again, if what are independent events? Okay, independent events. Okay, if two events are independent, so independent event means the occurrence of A won't affect the occurrence of B, and vice versa. Okay, and vice versa. Vice versa means the occurrence of B also won't affect the occurrence of A. So which means we have got the PA given B. We have got the PA given B. So if they are independent, so the B here won't have an effect on A, so which means PA given B is equal to PA if they are independent, yeah? Okay, so now let's compare. So PA given B here is 0.25. So let's compare with PA. PA is 0.3. So you see here, since PA given B is not equal to PA, thus we can conclude that A and B are not independent events. Okay, so we need to make full use of our previous answers, yeah? Okay, so that is how we answer the question. Okay, then next. Okay, so this question, a survey was implemented on 400 students at a private university. Okay, so we have got all the major courses and the minor courses. So you see here, I use distinct letters to declare the events. Okay, I use M for medicine, E for engineering, C for economics, L for language, S for statistics, and I for information technology. Okay, or okay, but if better if you can use not S. Okay, you can use any letter because usually the NS will represent, the letter S will represent the sample space, right? So you may choose any other letter here, but since I have written the S here, so let's assume S here for statistics, okay, not the sample space. Okay, so now if a student from this group is selected at random, so the keyword here is also a student. So what is the probability that he is either majoring in medicine or doing minor in information technology? So or here. So or means union, right? So it's either medicine or information technology. So medicine we have used letter M, and information technology letter I. So we are looking for probability of M union I. So in this case, because the union of two events cannot be obtained directly from table, so here we apply additional probability formula. Okay. Then, okay, by applying additional probability formula, PM union I is equal to PM plus PI minus M intersect I. So, okay, PM you can obtain here, M is 100 over 400. And then PI, so PI here 210 over 400. Okay, and then minus with M intersect I. So M intersect I will be here 60 over 400. So you will get the answer 5 over 8. Okay, so again, since 3 marks only allocated for this question, so make sure you allocate 3 minutes for this. Okay, then for the B part, okay, find the probability that the student is a non-medicine. Non-medicine means he can either take the course of engineering or economics, right? Because this is medicine. If M prime, so again, M prime is basically the E and the C. Okay, so this is what we call as M prime. Because when we talk about non-medicine students, so non-medicine student, it's either the student taking engineering or economics. Okay, so we can declare the E and C to be M prime. Okay, and yeah, M prime who does minor in language. So M prime intersect L. Okay, so who does a minor in language. So non-medicine, we use M prime. Minor in language, so intersect with L. So, okay, M prime intersect L. So you have, okay, so we look for this intersect L. So this is M prime. This is also M prime intersect L. So 80 plus 30 divided by 400. So you get 11 over 40. Okay. And then, okay, chooses a minor in statistics knowing that he is an economic student. Okay, so this is conditional probability. So S given C, so we use formula. So S intersect C over PC, so we will have the answer 1 over 7. Okay, and this is a bit tricky. Okay, so okay, what is the probability that the student is neither nor? So that means it's neither. So it's not engineering taking stats. Okay, nor, so it's not neither means it's not this, intersect with not this. Okay, so which means we can apply the De Morgan's law, whereby probability of A prime intersect B prime is equal to probability of A union B prime. Okay, so we are going to apply the De Morgan's rule. Okay, so this is De Morgan's rule. De Morgan's rule. Okay. Alright, so and then we can obtain the probability by using, okay, additional probability formula. So you add the probability, and then in order to find the complement event of this, so it's 1 minus this, okay, 1 minus the previous answer, and you will get this value. Okay, so now, yeah, it's the end for our lecture today. Okay, so I hope by now you are able to understand this topic very well. Okay, so if you have any further problem, then we will discuss during tutorial session. Okay, so that's all guys for today. So thank you for your presence. Thank you for your attention. So Assalamualaikum warahmatullahi wabarakatuh and have a nice day.